Hey everyone, what is going on? My name is Jeff Noble, and this is a Noble Cause video short. In this short, we're going to talk about the dotnet CLR, what it is, and how it works. I'm going to surround this story with complete bullshit, but I promise you by the end you'll understand how the dotnet CLR works. So let's get started. The dotnet CLR. This is a CPU, a central processing unit. This is the brains inside just about every computer. To program one of these, you need to feed it ones and zeros and ones. Programming in ones and zeros is not fun. There was this guy, Frank. Him and his buddies have invented every single programming language and compiler ever invented. See, I told you, this was all bullshit. Frank was not happy with his ones and zeros because it was really hard to type ones and zeros, and feed them into the CPU. Then Frank got together with the boys and they created assembly language. Assembly language could be used with a compiler and it could be turned into ones and zeros. This made Frank and the boys really happy. As you can see in the white box, assembly language still wasn't very easy to understand. It was basically 0x and a big memory address, and then you could give it a command what you wanted it to do to move data in and out of the registers inside a CPU. This was way better than ones and zeros, and Frank and the boys were happy until they weren't. One of the problems is assembly language also is not like English at all, and it's hard to write. The good thing is it's close to the ones and zeros, which is called machine language. The ones and zeros of machine language are considered a low-level programming language. Great for CPUs, bad for people. Assembly language is a bit higher level of programming language, easier to type and read, but still not that great. Frank went back with the boys and said, well, we have a low-level language and we have a higher-level language. Let's keep going up and we'll make a higher-level language called C. The reason it's called C is because Frank loves cats, and cats starts with the letter C. See? Once Frank and the boys invented C, which is a slightly higher-level language, they were happy. As you can see in the black box, C is a lot more like regular English, especially when you compare it to assembly language or machine language. You type in your C program, run it through a compiler that turns that language into ones and zeros, and the CPU is happy. Frank and the boys were thrilled until they weren't. The language C had a lot of complicated things in it like pointers and pointers to pointers and referencing and dereferencing. Frank got himself a spanking new job at Microsoft and he changed his name to Bill Gates. They then invented the .NET framework and a new language called CSharp. CSharp was kind of like C, and Frank and the boys were happy again. Sorry, Bill and the boys were happy again. CSharp relied on the .NET framework, which made a lot of common tasks simple. It was a huge success, and everyone was happy. But how would Bill get his fancy C# into the CPU in ones and zeros? He built a compiler. The compiler would read in the C#, process it into ones and zeros, and the ones and zeros could be run on the CPU. And this made Bill and the boys really happy. Until they weren't. Bill thought to himself, well, this works great on Windows, but it would be great if it could also run on my Mac, on my Linux laptop, on my mobile devices, on my tablet, and this brought up the need for the CLR. But how were they going to pull it off? How can you make C# code run on Windows, Mac, Linux, ARM systems like Android, iOS tablets, and anything else that comes out in the future? You can't just grab a program from Windows and run it on a Mac. Yeah, I know what you guys are saying about wine. I'm not talking about that. You also can't run anything from Linux on Windows the same way. So how do you solve this problem? You come up with the CLR, the Common Language Runtime. And here's how it all comes together. This is the Common Language Runtime. Its job is to take lower-level languages similar to assembly language, like we saw earlier, and turn it into ones and zeros that our CPU likes. The CLR's input will always be the same, but its output, the ones and zeros, will be very, very different. The ones and zeros generated by the Windows CLR will compile programs that run on Windows. The CLR that gets installed on the Mac will be able to compile Mac programs. Same thing with Linux, same things with ARM. So the Common Language Runtime gets installed on the actual computer and is a native application for each of the platforms. Once we've installed the CLR on Windows and another CLR on Mac and a different CLR on Linux, etc., we're ready to rock. But Bill had an issue. He didn't want to go back to assembly language. Instead, Bill and the team created MSIL, or the Microsoft Intermediate Language, also called the CIL for the Common Intermediate Language. I'm going to call it MSIL for the remainder of this presentation. MSIL is a little easier to read than assembly language was, so you can kind of glance at it and guess at what it's doing. As long as we could turn a .NET language into MSIL, the Common Language Runtime can turn MSIL into ones and zeros on each platform. This brings up just-in-time compilation, or JIT. .NET and .NET Core that we're learning in this course use just-in-time compilation. Here's how it works. Programs will get compiled into MSIL. That MSIL can be delivered to Windows, Mac, Linux, ARM, just about anything. When they're executed, the Common Language Runtime will take a look at the file and the manifest and other things that are compiled with the MSIL to determine, has anything changed? Did anybody change the program? Did programmers add a new feature? Was it updated in any way? Or has the program never been run before? If any of these things are true, then the just-in-time compilation takes place. The MSIL code gets turned into the ones and zeros that make sense for the platform that the CLR is installed on. For instance, I write a program in CSharp. I compile that program into MSIL. That lives in a file with a .exe extension for Windows. If I copy that file onto my Windows machine and run it or double-click it, the Common Language Runtime will inspect that file and it'll say to itself, hey, this thing's never been run before. It's still MSIL. I've got to run just-in-time compilation to turn it into the ones and zeros that I'm going to need to run natively. So it compiles it on the fly and it runs the program. The next time that program gets double-clicked, Windows and the Common Language Runtime will check the manifest and check the MSIL, and if nothing's changed, it just runs the same program. If something has changed or been updated, then it will run just-in-time compilation again, and then run the program. The same thing happens if we copy our MSIL exe onto a Mac. It'll make the same determinations, and the Mac Common Language Runtime will run its just-in-time compilation. And it works the same on every other platform. The next job was, how do we take C# and turn it into MSIL? We need a new .NET Core compiler. The compiler is also called Roslyn. Roslyn can take any .NET language. We're only talking about C# for this course, but there are plenty of other languages that work under .NET and .NET Core. Roslyn will take the C# code and convert it to MSIL. At that point, it goes through the same Common Language Runtime routine we just covered. This made Bill so happy. And that's the history of the CLR and how it works. Bye for now.